All right, so let's go ahead and finish our slope function. We actually missed a step. Let's see, let's open up our design steps. There they are. Let's rearrange our screen. Oops. All right, we actually missed purpose. Before we make the stub, we should have made the purpose. So let's do that now. The purpose of this function is to calculate the slope of a line given 2 points. All right, that's good enough. Compile, no errors. And then we have stub, that's done. And now it's time for us to define some examples. Okay, so let's say if we call a slope, let's make 2 points first. So let's say point A is, say, 1, 1, or 1, 2 maybe. And then point B is, say, 4, 6, something like that. When we call slope, this should be B. When we call slope, given A and B, we should expect to get back, let's see, let's go back to our formula. It's y2 minus y1, so y2 is 6 minus y1, 4. Let's write that down, 6 minus 4 divided by x2 minus x1. x2 is 4 minus 1. All right, so let us calculate what that is. Let's put our parentheses there. Okay, so it's 0.6. So let's say we're going to expect 0.6. All right, so let's put that in print. \n equals %f. There you go. Let's accept slope. And then the second thing we'll give is our expected result. So 0.66f. Yeah, that's good enough. All right. And then now we can delete till 1 there. Okay, now time to run our code. So done with examples, we'll just have one for now. And then now it's time for us to compile and run. So let's compile. Don't forget all warnings. And then let's run it. Okay, so the test fails, but there's no error, so we're happy about that. The next thing is to write the template. Okay, so when we're working with structs, the templates become a little different. So let's comment this out for now. Let's call this the stub. And then we'll comment this out. Okay, so when we're making templates for functions that accept structs, the templates don't just look like ... A and B. What happens is that what we want to do when we make our template is to lay out all the pieces of data that we have, and we should unpack all of the structs that we have in our parameter list. So for example, if we had A and B, we wouldn't just say A and B, we would unpack it. We would say A.x, A.y, and B.x, and B.y. So list out all of the individual members of your struct. Okay, so that won't compile. Comment that out. And then we'll label this as the template. Okay. And now it's time for us to make our body. So template and inventory, and then body. We know that the result should look something like, where was it? y1 minus 1 to y2 over x2 minus x1. So let's write that out. y2, so b, return b dot y, y2, minus y1 a dot y, divided by x2 b dot x minus x1 a dot x. All right. Let's parenthesize that completely so that we don't make any mess ups with our precedence rules. There you go. Okay, compile. All right, it should work. Okay, let's see what happens when we run it. Didn't expect that. Okay, so I think the problem is because we need to cast this as a float for it to work. We'll see. See if this solves the problem. Yep. Okay, I think that's correct. I think what's wrong is our example. Sakto ba? 4, 6 minus 2, 4, divided by 4 minus 1, 3. So 4 divided by 3, yeah. So sa'yo pa tong example. It should be 1.33. All right, let's see that again. Okay, that's fine. Okay, so that's it. When working with, the only thing that's different when working with structs is that the templates are different. Instead of just putting the names of the parameters, we unpack each of the structs and put them out in the open, all of their individual members.